Hey, Mark,
Hey,
it's time to
Virch.
go. We just got our go signal.
Yay.
Welcome, everybody.
Welcome to AB Calculus AB, right?
Right.
I am Mark Corrali from Ryan High School in Denton, Texas.
And I'm Virg Cornelius, Lafayette High School, Oxford, Mississippi. There's more popcorn on there from yesterday, isn't there?
I think it's the same as yesterday.
Oh, it's the same. I didn't notice one in Canada last time.
Yeah, and the Wisconsin popcorn moved to Minnesota where it should have been. All right, so it is Tuesday, April 28th. It says we're doing graphical stems today. We'll see how that goes.
Yeah. We're going to finish up what we did yesterday. We have 2 questions remaining from yesterday, and then the graphical stem. Yep.
And May 12th is the exam. I know teachers are watching. There's a webinar tonight about what this interface is supposed to look like for the test, and hopefully get some resources out to you guys so you can see what it's going to look like before May 12th. And we were so excited about this until about 20 minutes ago. It turns out we got a mistake yesterday.
Yeah, and we were notified by a student about 20 minutes ago.
Well, a teacher, but their student is the one who spotted it.
Oh, okay.
Yes,
Okay.
and this is a screenshot. I just tried to go under my camera, and we just decided this A was wrong. So this 7.5 can't be 7.5 because these are the only 2 critical numbers. So the derivative has to say negative this whole time. So this has to be a number less than 2. So we're going to change that to a 1. It is going to change the answers to B and F. Because it'll change that trapezoidal sum and how many times it's going to cross its average. So, or how many times the intermediate value theorem can be applied. So we will put corrections in that answers when we put those answers up. And hey, sorry, that's what you get when we write a 12-part question.
And thank you for bringing that to our attention. That's really slick. We love that. But it does only affect B and F. And so Mark you'll see the corrections by tomorrow.
Oh, and I just quit the screen slideshow. So.
Hey, we're huge.
Hey, yeah. I'm gonna put that back up. Man, error's just flying now. Okay. So anyway, so where are we going today after we fix that? We're going to finish off I and J from that table, from that medley. It is not going to affect I and J, so we're okay there. And then we're going to do today's graphical medley, as much of that as we can get in, and that is in today's shared folder. It went in there about 12:15 my time, so 1:15 Eastern. And
you want to have a joke or what before we get started on I and J?
Or do you want to wait until I have an awkward time where we need a joke? That may happen.
Maybe I'll save it. If we don't get to it by the end, then we'll do it at the very end. How about that?
Set off an internal mental alarm for 1:05 or something like that. Am I sharing the slideshow right now, by the way?
Nope. If you are, I can't see it. You're talking about the PowerPoint?
Yeah, it's right here. Okay.
Oh, right. This is so confusing because this looks like my hover cam, but I'm actually not going to use my hover cam at all today. But I said, Mark, I have such a cute picture of a taco. You have to show this and remind everybody that it's Taco Tuesday, which seems to come around quite frequently these days.
Yes, in episode 25.
In episode 25, right. This is actually sitting on the notes page for today, but like Mark said, he's going to finish the I and the J from yesterday. So you can go ahead and switch over to your document camera.
And before I do any more disasters with that slideshow, let's just continue. Okay. All right, so here's my hover camera.
Yeah.
Whatever you want to call it. All right, and so there's our corrected table. We have got that number 1, and we're going to look at B and F. But for I and J, it is not going to affect us, so we're just going to charge on through. In I, it says there's a gecko scurrying along a straight path such that the velocity of the gecko v equals f prime, where velocity is measured in centimeters per second. Find the average acceleration of the gecko on the interval 512. Indicate units of measure. And I know average value of functions is not on the exam this year, as far as using an integral, but the average value of this function could easily be in the exam. How do you find the average value of this function?
Well, so let's see here. We were trying to figure out the average acceleration. So that's going to be the change in velocity over the change in time. And so we were told that v is equal to f prime. Yep. So we would do like what, f prime of 12 maybe minus, oh yeah, you're doing it.
Well, you're doing
Yeah,
a good job.
over
So,
12 minus 5.
So
Yep.
f prime 12 minus over
Minus
12
f.
minus 5.
Yep.
You steered me right into the correct stuff. So I just
Okay.
plugged along. I'm going to adjust my camera here. I'm nearing the edge of my surface.
Yeah.
So we have f prime of 12. We're going to pull that off the table.
1.
And that is 1. And f prime of 5 is -2. And that looks like 3/7.
Mm-hmm.
And it says to indicate units of measure. So average acceleration is 3/7, and we are looking at centimeters per second for the velocity divided by time one more time. So centimeters per second, or centimeters per second squared.
Nice.
All right, on to J. J says, explain why there must be a time in the interval 5/12 where the acceleration of the gecko will be equal to the value found in I. So now they're not talking about average acceleration, they're talking about actual acceleration.
Mm-hmm. The acceleration. So that implies the instantaneous acceleration. Mm-hmm.
So we're looking for A of t equal to V of t, or V prime of t. It says, explain why there must be a time in that interval where the acceleration of the gecko will be equal to that value. I think we could we do this 2 different ways?
Let's just use mean value
theorem. Let's just use mean value theorem.
Mm-hmm.
So at V prime is going to be F double prime.
Mm-hmm.
So to find A equal to V prime equals F double prime, well, let's see. That's got to happen. We're looking at, well, F double prime, which is V prime, which is acceleration, right?
Mm-hmm.
Is continuous. Because, oh, well, we're actually looking at V prime. So it's not, we don't really, A may be continuous, but we don't care. Or maybe we care deeply, but we're not going to discuss it.
Mm-hmm.
V is continuous on 5/12. And V is also differentiable on 5/12, since F is twice differentiable.
Nice. Yep.
Because we were told back in the stem that F is twice differentiable. So F prime, which is V, is also differentiable. So that gets me everything I need for mean value theorem, right? So there's a V prime of C, which will equal F prime of B minus F prime of A. Now this is not enough. This is just a formula. This is going to get me going, right?
Mm-hmm.
So V prime of C also, there is an A of C.
Since that's equivalent to V prime of C. It's just a substitution.
Where F prime of 12 minus F prime of 5 over 12 minus 5 equals 3/7.
Mm-hmm. Make sure that prime on your F prime of 5 is a little bit more visible.
Yeah, it kind of merged into the parentheses.
Emerged into the parenthesis, yeah.
Yeah, and so there is an A of, there is a C, I guess. There is a C such that. And I think I'm even gonna, it's great to have an eraser.
Yes.
I know pens are fun, but if they're not erasable, okay.
Oh,
so there's a C in between 5 or 12 such that that is true. It's by mean value theorem, but I don't have to say by mean value theorem. Yeah.
Nice.
I like the eraser. You're right. This is why we don't finish though, right?
Right. So, yeah. So just caution, if you do use these pens a lot, which I do, and now Mark does, and if you have a hot cup of coffee, which I often have, and you set it down on your sticky notes because your desk is covered in them that have the purple writing.
Where is this going?
Your writing disappears. It becomes like invisible ink because
this
ink, the way that this works is by friction, and friction creates heat. So it's an eraser, but not in the traditional sense of like a pencil with an eraser.
Not like a piece of bread or a piece of rubber.
Yeah, it is really, yeah, anyway, it's pretty neat. Anyway,
Yep,
and now
that's
we are
fun.
to our next problem. How exciting is that? This is what's in the Dropbox. This is the graphical STEM medley. Way more questions than you'd have to actually answer
yes,
on that
way more.
25. But what we wanted to do was just try and get a nice variety of questions together that you could answer by looking at one given graph. That's what that graphical STEM means, that there's one graph that's given.
Right. So
here it is.
All right. So we have this, we see this graph that starts at -5, 2 and ends at 4, 0. It says the graph of f, a continuous function on the interval -5 is less than or equal to x is less than or equal to 4 shown above. The graph of f consists of 5 line segments and 1 semicircle. You can see our 1, 2, 3, 4, 5 and semicircle of radius 1, it looks like. Let c of x equal the absolute value of f of x on this interval from 0 to 4. So for this part, we're only using this side of the graph. And what is absolute value going to do to that function?
It's going to make any negative y values positive and keep any positive y values positive. So the c of x graph is going to exist only in the first quadrant because that domain says 0 to 4, and then also that semicircle is getting flipped up.
Yeah, so c of x is going to look like that.
Yep.
It says find c of 1. So if this
you gotta say what it models. You gotta read that part too.
Oh, yeah. Did I not? Okay.
Yeah.
Models the number of people in 100 in a warehouse X hours after 8 a.m. So this is my 8 a.m. And then a couple hours later, for some reason at 10 a.m., maybe it's a break or something, they're cleaning, and then it peaks again. So it says C of 1. So C of 1 is just going to be that point. C of 1 equals 1. And how to interpret that. So I would interpret that as 1 hour after 8 a.m. because X is hours after 8 a.m. Now, of course, I could just say at 9 a.m. there are 100 people in the warehouse.
Yep.
All right. C prime of 3.5. Well, now things get more interesting. So this is dCdx or dCdt. I guess they did use X. They. I do that in class all the time too. The author did something really nasty right here. Kids are like, didn't you write this?
Yeah.
So we're looking at 3.5 right here. So what's the derivative of that? Well, that portion's a line segment. And if I go up to my nicer graph,
yeah, so that's
3.2 to 4.0. So down 2 over 1.
So we're thinking about slope there. We're thinking about that feature is going to be -2, down 2 over 1, like Mark said.
And now interpreting this. So 3.5, well, this is C of X here. This is still C prime of X. So 3.5 is still an X. So 3.5 hours after 8 a.m. And again, a lot of people would just say at 11:30. I will say the number of people, because C measuring number of people in the warehouse. And now, again, this is a slope. So what gets hammered into us in 7th, 8th, and 9th grade for what slope represents?
It's a rate of change.
It's a rate of change. So the rate of change is -2. So the number of the warehouse is decreasing. And I think I originally said at a rate, but I think it's redundant. I could say is decreasing.
I think we said by
200.
Oh yeah,
people per, and our time units are hours. So per hour. And again, I can come over here and get my units because C is measuring people and X is measuring time. So. Yeah, and you can say it's decreasing 200 people per hour or at 200 people by 200 people per hour. I think prepositions are okay there. And a lot of people may just say the rate of change of the number of people is, and lots of ways to get that. There's definitely more than one correct interpretation, I think. But the thing you want to avoid is you want to avoid it sounding like an algebra slope. It needs to be instantaneous. It needs to be at that time. All right, are we ready to move on to K?
Yes.
Okay.
I don't know if you want to cut off your graph and then stick your graph under there so we can see what's going on a little better, or
I actually had brought, it transferred to the other page. I actually had brought a graph down. But yeah, why don't you tell a joke while I cut that off?
okay. What do you get when you cross a mosquito with a mountain climber?
Oh, I actually think I know this one. I actually know a setup for this, which makes it even worse. But what do you get when you cross a mountain climber and a mosquito?
Nothing. You can't cross a scalar with a vector. Yeah.
I think that may be the one I always preface as, this is the worst math joke I know.
It's actually a great physics joke. So
Oh,
those of you who are in AP Physics should send that to your teacher, see if you get some extra credit.
Back when we used to do more vectors in pre-cal, I used to do a version of that where we talked about crossing an elephant and a grape, and it's, I don't know, but it's the size of it is equal to the size of the elephant times the size of the grape times cosine of the angle in between them, and you get it so that kids memorize that dot product thing, and or the cross product, sorry, that's related to cosine. And then after you get it where they're repeating it without thinking, you throw the mountain climber in there and you can't do it. He's a scalar.
Okay, push your graph up just a little bit more. Okay.
Jeez, be so pushy. Okay.
I know, sorry.
All right, so now K of X is equal. So now we're seeing this traditional setup that if you've seen a lot of FRQs, you've seen this. If not, then welcome.
Welcome to the party.
Welcome to what's going to happen a lot of times. K of X is being defined as this integral from 0 to x of f of t dt. And so there's two relationships that get built in there, right? That K prime is now f of x, which we're going to use. And this graph I can use as an accumulator to find these integrals. So I've given myself a little space down here. I think I'm actually going to scoot the graph there. It's probably behind my face, but that's okay.
It's okay.
For now.
No, it's good.
We're going to find K of 1. And K of 1 is the integral from 0 to 1. I'm just plugging my 1 in for my x's up here of f of t dt. And I'm actually going to look over here and, oh my goodness, we're looking for this area right here.
And we don't.
And even if I had that equation, it's negative square root 1 minus x squared. That's not an integral that, or an function we know the elementary antiderivative of, or at least we in Cat 1 don't. So how do we find that type of integral? Well, we use our geometry. How much of a circle is that?
It's a quarter circle.
A quarter circle. I'm going to go negative because it's below the graph. And since this is I made the comment that this is actually K prime, so this is telling me how it's changing. So it's decreasing however much this area is. And the radius is 1. I think we need a pi. Negative pi over 4.
Yep. So that area is below the x-axis. So this assigned area, the negative is that showing that direction.
All right. I realize I've been using red a lot, so we're just going to change things up.
K prime of 1.
So K prime of 1. Well, I had mentioned earlier, but I can mention it again. K prime is f of x, fundamental theorem of calculus. You take this derivative, you plug the x in. If that x has any kind of function going on other than just x, you chain it out. But of course, this would chain out 1. So this is a straight substitution that K prime of 1 equals f of 1. And f of 1 is that point, which is negative 1. It was 1 on C, but that was because C was the absolute value, right? So we're kind of showing you how you can just use these lots of different ways. They're very rich problems. You don't really know what to expect right away when you see them.
Yeah, and take your time when you first open up that exam. Take your time to digest. Don't start panicking. You're going to
No.
have plenty of time. You
Look for these
probably need,
relationships, right?
yeah, you probably need like 4 minutes to read it and kind of jot stuff down and start, you know, digesting what the problem's asking you.
Yeah, look how much time the math actually takes to do, right? Once you know what to do, that's always my joke with my kids. Like, I guarantee you'll know how to do every problem on the test. The question is, are you going to be able to recognize that you know how to do every problem on the test?
Right. 'Cause sometimes it's
So,
hard to know, do I take the derivative? Do I anti-differentiate? What am I supposed to be doing here?
right.
And that comes with digesting the given information.
All right. So now we're going to move on. That was B. A was the C questions, by the way. So there's no A for K. C says we're going to find the average rate of change and there are, if you've heard AROC, I don't use AROC in my class, but I know a lot of teachers use AROC. The average rate of change of K of X. And I'm just recopying the problem because I want to scoot that graph down. So I need to find average rate of change.
That's the slope of the secant line.
The slope of the secant, yep. So the slope of my secant is going to be K of 5, negative 5. I guess if we want to go right to left.
It doesn't matter actually, but
no, it doesn't, as long as we're consistent, it's okay. So K of 0 minus K of negative 5 over that F of B minus FA over B minus A that we've seen several times. So K of 0, well, we don't have K of 0 yet, do we? But K of 0, again, my function is just the integral from 0 to X. That's pretty straightforward.
Ooh, that turned out to be 0.
No
We're
width.
not going anywhere.
So that's fine. And then K of negative 5, I think this is the one that's going to take a little time. This is going to be the integral from 0 to negative 5 of f of t dt.
Plugging into that upper limit.
And then I'm going to go ahead and rearrange it so it goes left or right. You don't have to do this. You could just do opposite, but hey, whatever makes it work. So now I'm going from negative 5 to 0, adding up all this net area if we sign it as a positive and negative signs. So I'm going to put that negative out front so I don't forget it. And then I'm going to go ahead and start marking up my graph. This one is a 2 by 2. This one's a 2 by 2. So half of 2 times 2. If I wanted to show it, I could. You can use symmetry, but I would double check the symmetry because graphs can be very deceiving. And then this graph is 2 tall and 1 wide. So if I do base times height, and then I'm going to go ahead and write those other 2 in, but so those cancel because this one's negative. Again, we're subtracting that one because this is our F prime, our K prime, sorry. That's our change, it's a decrease. Those are all going to cancel. It looks like I get negative 1. So minus negative 1.
Yep.
And looks like 1/5.
Yep.
And just a cursory look at it, there's more above than below. So that average rate should be 1/5, right? All right. There's a D.
There's a D.
There's a D. There's actually what, I or J again. All right, so give myself a little space here. Sorry, move the blank paper to the top. All right, now let's see. Haven't used green yet today. All right, so D says, okay, K satisfies the MVT.
It's telling us that K
says
satisfies.
verify. So we know it does. We need to show it. Okay. So we need to verify that. And a negative 5, 0. And state how many times K prime of C, the value guaranteed by the mean value theorem, occurs. So First off, what has to happen? Well, k has to be continuous. And k has a derivative that exists everywhere on this interval because k prime equals f. So we can say,
go ahead and push your paper up just a little bit.
Thank you. Or scoot my camera down, however I have to. Thanks.
By the way, as Mark is getting this organized, this is like pretty much the exact same problem that we led off with on the tabular medley. Oh, how clever, you changed your background.
Yeah, I thought that was a good timing.
Yeah, but this is pretty much the same thing. And you might think, oh gosh, we have to write that all over again. You know, we have to state those conditions for the mean value theorem to show that there's at least one place where the slope of the secant line is equal to the slope of the tangent line. Or maybe now we're trying to see exactly how many places there are. But yes, it's important for the mathematicians who read your paper that you state those conditions. Show how you know.
I'm actually going to leave that closed because they told us that we can see that the derivative exists on those endpoints.
So k is differentiable on that closed interval -5 to 0, and thus continuous on that closed interval. Therefore
there is a c, and I'm gonna use interval, a bit of set interval notation here. There's a c in between -5 and 0, such that k of c, is it k of c or k prime?
It should be k prime of c.
Oh yes, right. The derivative has to equal the k of -5 minus k of 0 over -5 minus 0. And I flipped that this time, but well, what a coincidence, right? We have that. And we know that k prime of c equals 1/5. So we got the verify part there. And now how many times? Well, we look at our graph, and this is f, which is k prime. So if I come through at about 1/5, how many times does it occur? 3 times.
And the reason he's not going over and including those on the other side up in the first quadrant there is that his interval is only from -5 to 0. Yep.
I don't know what's going on, but you were just clicking in real loud all of a sudden.
Huh, that is weird.
It's happened twice today. So I'm reaching down now and grabbing my volume. It's fine. It's just like all of a sudden, it's like, because I'm not seeing you, like, you know, it's not like you're leading in. So it's like when you sneak up on someone. It's like I was like, wow, she's in my head.
Yeah, and not only that, I mean, like how much time do we spend video conferencing anyway per day? Like way more than 45 minutes. So that would be weird that the volume is flipping out on you.
I almost wonder if my headset, because I was doing I've got a different setup today. If it's my hubs, am I coming through okay?
Yeah, I can hear you.
Okay. All right. Because that would be bad since I'm the one doing all the writing today. All right. So that was fine and good. We've got 15 minutes left for 4 parts, and you think,
I think we can do it.
You're thinking we'll get done early today, and I'm thinking we're going to just make it. Because I love this problem.
Yeah, this is the same graphical stem.
Same graph. In fact, on the copy that is in the Dropbox, you only get the graph, I think, once. I may have put 2 little ones in there, but I spaced this out because I knew I was working it.
So now we've got h of x is 2 plus this definite integral. Ooh, the lower bound is not 0 anymore. That makes it interesting.
And there's constants.
And then there's like a f of t minus 1 in the integrand instead of just an f of t. So this is a much more complex function than k of x was. And so we're going to handle it a little bit more with, you know, white gloves, so to speak.
There's a lot going on in here. Yeah.
Yeah.
So I'm just gonna do it now. The old joke about how do you eat an elephant, which you shouldn't. They're endangered. But
one bite at a time.
You
can only do this one bite of calculus at a time. That's right.
Don't try to be a Python and unhinge your jaw and take it all in at once. You just take it piece by piece. So we're gonna start with our h of -2, and I'm simply gonna write a -2 where the x was. And I'm actually going to be really happy about this.
Me too.
Because I love that when that integral has a width of 0, the sum of this is 0.
Yep.
So h of -2 is just 2.
Mm-hmm.
Well, that was good. See if we can keep that up. All right. I'm actually going to come up here and do my h prime. I guess I'll do it right here. H prime of x. Well, the derivative of 2
Is 0.
is 0, and I could write that or just like ghost it. And then the fundamental theorem of calculus is everywhere I see a t in here, I'm going to replace it with an x. So the function f of t minus 1 that was our integrand becomes our result, f of x minus 1. And
So
then,
that's the formula for h prime.
and I check, and I only plugged a simple x in, so the chain is 1. So that's my h prime is f of x minus 1. And I'm not going to ghost that completely, just so we have a nice statement. So h prime of -2 is going to be f of -2 minus 1.
Mm-hmm.
And I come over here, and f
This
of
is the graph of
-2.
f.
Yep, this is f, right? F of -2 is 0. So 0 minus 1 equals -1.
Mm-hmm.
So far, so okay.
Mm-hmm.
Have a little bit of space left. All right, h double prime at -2. Well, if h prime of x is f of x minus 1, then h double prime of x is just simply going to be f prime of x.
And writing those relationships down is really, really important. Sometimes it's worth a point on the AP exam. So it's not just for you to keep your head in the game and know what's what. It's really to earn points. So make sure that you're being clear.
Yeah, and in the section you use it. Don't do a bunch of shotgun stuff in the section A. It might get you points, but it's better to repeat it if you need to, just because formulas don't get points, but you make it relevant to your problem, and suddenly you're earning points. So, slope of this line looks like it goes up 2 over 1, up 2 over 1. So f prime of -2 is going to be the slope of that line segment. So,
Yep. And again, I know that I'm looking for the slope because f prime means slope, and I'm looking at a graph of f of x. So that's a feature I'm looking for.
First, check me on that, because I want to make sure you have your answers from when
I
we went through this
do.
earlier. Okay.
Yeah.
We're okay.
Yep. Check it out.
I'm nervous about those being the same.
Yeah, no, they were the same.
Okay, good.
We're good.
As I knew they would be. No.
Mm-hmm.
All right. So that was kind of cool for E. So let's look at F. And this is kind of an alphabet soup problem, isn't it?
Yeah.
H of 0. Well, now we're going back to our definition again, right?
Mm-hmm.
So 2 plus -2 to 0. F of t minus 1. Oh, but this one's a lot more difficult. You're thinking, why are they making us do h again? We did it up here. Yeah, but what was the width up there? That was a nice 0. It didn't go away. And
yeah.
Now we've got more stuff going on.
Yeah. Yeah.
So,
definitely.
I'm not gonna try and chain this out too far, but I'm gonna run one more here. -2 to 0. That's the correct left to right order, isn't it?
Mm-hmm.
So we're gonna leave that, but I am gonna break this sum, or this, it's actually a difference, into 2 integrals.
Yep.
So I can, because remember, all a definite integral is a Riemann sum. We're adding up a bunch of infinitely tiny rectangles. So I can break it up and find all the rectangles for f of t and all the rectangles for -1, and then put those together at the end. So I can break that up. And that -2 to 0, that is just this triangle, I believe.
Yep.
Which has a base of 2 and a height of 2.
And yeah, which is, we knew that was 2 from before.
Yeah.
So.
And if I want to do a definite integral on this, I can. It's going to be 2. It's a width of 2 with a height of 1. So that's going to be 2 plus 2 minus 2 is 2 again. No.
I think it's
6. It's 6.
It should be 6, but now I'm confused as to why.
Because of that minus and -2 to 0.
Oh, no, h of 0 was 2. That's right. We did these in a different order this morning. This is correct. Yeah. Whew.
So much more nerve-wracking for us than for you, but
yeah, but there are a lot of twos in this
incident.
Yeah, there are a lot of twos in this problem, and so you just got to be really careful about that. Make sure your upper limit there is -5, Mark.
So, all right. So I probably would have caught that when I finally read it, but I was just writing while you were going ahead.
So now he's going to go
so
ahead
h
and
of
do
-5. So
Yep.
again, I'm using my definition, which is up here at the top, still barely. -2 to -5. And when I break this one up, we're going to do a couple. I'm actually going to take more steps with this one. That's why I brought that blank paper in. I'm going to reverse that so it goes left to right the way I prefer it. And you could do some of these steps 2 at a time, but again, it's that one bite at a time sometimes is not a bad idea.
Go ahead and push your paper up a little bit, Mark.
So now I changed the bounds from -5 to -2, so we're now subtracting this integral. And now I'm going to do the same breaking up that I did earlier. Minus a negative, so it's going to be plus. I don't know why I don't know if I can do it without doing the sound effects. So I go, and then I'm like, why did I do that?
It's like you had sound effects before there were like computers sending emails.
Yeah. It's because I was 6 when Star Wars came. That's all right. So from -5 to -2 is going to be that positive triangle. That's 1/2, 1 times 2, minus that guy, that 2 by 2. And then we're -2, so we stop.
Okay, and show the graph just a little bit. Bring it down so we can see.
So this was the, I can actually scoot the work up. So this triangle, sorry, is 1 wide, 2 tall. So that's the 1/2, 1, 2. And this one is a negative triangle, sorry, -1/2, 2 times 2.
Can I just make a comment about that, Mark?
Yes.
Okay, so if you look at that minus, like show your work again there. Yeah. Okay, so when I do those, just so I say that the depth is -2, so I actually
add it with the -2.
Yeah.
And I do that too, arithmetic wise, but when I'm talking through it, it feels wrong. So because then you're giving a measurement as a negative, and
well, it's just the direction of it, right?
And a lot of times I'll do symmetry too, where I would just cancel these two out and then do that.
And then you have like a -1 left there or whatever.
There's so many fun alternate paths.
Yeah.
And this, I lost a negative again. My bane. Okay. So that has a width of 3.
Yep.
And a height of 1. So I'm just going to replace it with the 3, guys. I'm sorry. It's one less place for me to make a mistake. And then this is 1 minus 2. And that does equal 6. So.
Great.
All right. So we've done a lot with H so far, but it's just been a lot of evaluation. Find a point, find a derivative, find the second derivative. Now we're going to start using those things. And I am going to just go equals 6 here for my work, so I can use that. So in G, it says write an equation of the tangent line to h of x at x equals -2. And again, if you've been watching since Friday, you'll notice they keep doing the same problem. It's like Verge said, like that MVT. It's like, we're getting tired of tangent lines. That's because we want you to do them without thinking.
Yeah. I mean, I think,
I can't tell you.
That's like the whole point of calculus, is being able to use something linear to describe something that's much more complex. And so, like, it happens in stats as well, but for different reasons. So make sure you're not using any statistic.
And for the BC teachers and students, I'm going to say the whole point of Cal 1 is to use linear approximations. Oh, because we use polynomial approximations in Cal 2.
Oh, of course, yes.
But this is the seed, right? This is the 1 degree polynomial.
Yeah,
Write an
that's a
equation
polynomial.
write the equation of the tangent line. So I can't think of anything that would make me happier on May 12th is if you hear my voice, my raspy, non-distinguished voice in your head go, what do I need? I need a point and a slope.
Mm-hmm. Yeah, because if
And
you
then
don't talk
and
to
then maybe
yourself
you'll
while
hear-
you're doing math,
yeah,
maybe
and
you
then-
can talk to Mark.
and then maybe you'll hear Virg's laugh in the background. All right. So we need a point at -2. Hey,
We done did it already.
h of -2 is 2. We have a point. Oh, good. Now I just have to find h prime at -2.
Because that would be the slope, right?
That would be the slope, would be h prime.
Okay.
Hey!
Oh, we did it already.
So my
Now,
tangent line.
let me just say that, like in real life, a lot of times you haven't already done those calculations. You have to, that's your launch point, and you have to go and make those calculations, you know. But now you know that that's how you would go ahead and do it.
Yep. And I'm going to I'll use Virg's traditional form of the point slope form and do 1 minus 2 is equal to my slope times x minus -2 or x plus 2. That was pretty nice.
Yep.
All right. And I brought the graph back for a reason on h, right?
Ooh, h is a lot going on.
Hey, you know what?
What?
I didn't print I.
I have it. We can switch to my screen if we need to.
So h, we're going to get through h pretty quick, actually. On what open intervals is the function h of x increasing and concave up? So for increasing, for an open increasing interval, I want to know where h prime of x is greater than 0. Well, way back up here at the beginning, we said h prime of x was f of x minus 1. So that's just a straight substitution from our definition up there at the top. So I want to know when f of x is greater than 1. And this is my graph of f of x over here. So
he's doing a horizontal line.
Anywhere above this line is where h of x is increasing. So it's increasing here, 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 and here. So those are my 3 intervals where h of x is increasing, my open intervals. Open and concave up is going to be where the second derivative is greater than 0. I'm not going to scoot the page again. I don't want to make you seasick. You can grab it from over here if you want. But that's going to be where f prime of x is greater than 0, or f of x is increasing. So f of x is increasing on this line segment, this quarter circle, and this line segment. And we want both, right? So these are linear with slope 2, so these are actually easy points to find. So on -1.5 until -1.
Yep.
And these are increasing, but they're concave down. This is all concave up, but it doesn't start increasing till here at 2.5 to 3.
Yep. You did that correctly, Mark.
Thanks. Don't sound surprised.
Well, I mean, you didn't do it correctly today, this morning, whenever that was.
I did it correctly. I just wrote it wroong.
Okay.
That's
You sound like my students. Like
a stupid sign.
That's what I really meant when I wrote that. That's what I meant. I'm like, but that's not what you did. So I can't.
I would have made a 5.
If I had a crystal ball and one of those, like tarot cards, yeah. I actually have I. If you want me to.
Is I the limit?
Yeah.
Okay, so we're on our last one. I know it's 1:45, but we're gonna finish
No, we're
this
gonna
out.
do it. This limit's awesome. Do you want me to do it, or you got it?
The limit is x goes to 12, I believe. Yes.
It's the limit as x goes to, oh, I don't know what it is. I thought it was the limit as x goes to 1.
I can pull it up. Oh, no, it is 1. You're right.
Yeah, it's
The
that
12,
one.
the 12 was yesterday.
Mhm.
That's old
Yep.
news. All right. And
Limit
is
as
it,
x goes to 1 of k of x plus arctangent of x. And arctangent is the same as inverse tangent.
mhm.
All divided by 2x minus h of x minus 3.
Quantity x minus 3, yeah.
Yeah, the quantity.
All right, man. Again, who wrote this?
We did.
Oh yeah. Who came up with this scary stuff? All right. So I've got some papers I can finagle around here. K of x, you might not remember K of x anymore.
That was like 20 minutes ago.
I may have misplaced K of x.
I know K of x. I remember what K of 1 is because we actually found it.
Oh, yeah, good. So what is
Yeah.
K of 1?
K of 1 ended up being negative pi over 4, actually.
Yeah, we found that. So we know K of 1 is negative pi over 4. These are all continuous functions, so I can plug in and evaluate if that works.
That's what you always should do first, is direct substitution and check and see what's going on. Don't assume it's L'Hopital's rule or some other something.
So
what about the arctangent of 1?
So arctangent of 1.
Yeah.
And my camera scooted over. Sorry about that.
That means
when arctangent of 1, so we're saying tangent equals 1. So what line has a slope of 1, or what angle for an array would have a slope of 1?
It's happening at pi over 4.
And that's going to happen at pi over 4, which is 0. When it's added to that negative pi over 5.
Mm-hmm.
Yep.
So direct substitution on the numerator yielded 0. What about in the denominator?
So as I go into my denominator, and I'm gonna go ahead. Yeah, we'll leave it as x. So this is 2 times 1 minus h of negative 2.
So h of negative 2 we found to be 2 earlier.
So that's why
2 minus
it's a 0 over 0.
Yeah.
So we're going to get to use L'Hopital's rule. So by L'Hopital's rule, we can just take that limit and do as x approaches 1 of k prime of x. Oh dear, what is the derivative of arctangent, Verge?
Oh, it's my favorite. I never forget that one. It's 1 over 1 plus x squared.
Oh,
yep.
Yeah, that plus is the t for tangent, right? Something like that. And then in the denominator, my derivative of 2x is 2. My derivative of h of x minus 3, it's a composition, so it's h prime of x minus 3, but if I do a little chain rule, it's times 1. So. And now if we try some direct substitution, what was k prime of 1? We found that earlier as well.
Yep. Let me look at my notes. That was negative 1.
And 1 plus 1 is 1 plus 1 squared is 1 plus 1, which is 2. So plus I have, so we're not getting 0 on top. And I have 2, and then h prime of negative 2
is negative 1. We did that earlier as well.
Yep. And so we're going to get 1/2 over 3, or 1/6. Negative 1/2, negative 1/6. Wow.
Yay!
I'm wiped out today.
Yeah, that was awesome. I'll do everything tomorrow, Mark, okay?
Oh, cool. I'll sleep in. My son got up about a half hour before we went live. I'll just do the same. No. He just heard him. So thanks everyone for watching. We apologize about that table from yesterday. We'll get it corrected in there tonight sometime. But thanks for joining us. It's a Tuesday, so it is 2 weeks until the exam.
Yeah, this time, 2 weeks from today, you will be done with your AP Calculus exam. Yeah, you'll even be done with the upload. You better be.
All right.
All right. Thanks for watching, everybody. Are you going to put that last slide up, Mark?
Got to get the slideshow going. You're
Yeah.
From current
Yeah.
slide. Boom. And all of our typical slides. There's our calendar. There's your test information. There's Dropbox. It's down in the description. Thanks for watching.
Bye, everybody. See you tomorrow. Good times.